topic is about threat cluster memory scheduling. It's also known as TCMS. Introduction to threat cluster memory scheduling. It is the TCM where the scheduling is a technique used in a computer system to optimize memory access for multiple threads and also for running or processes. It also involves about the grouping of threads into clusters based on the memory access patterns to improve overall system performance. And we can see here the implementation cost. It requires storage of memory controller around the thread memory behavior, and it also involves about grouping threads into cluster based on their memory access. And this grouping threads improve overall system performance by prioritizing memory requests within each cluster. The cluster memory scheduling can reduce memory context and improve resource utilization. And this is about introduction of the cluster memory scheduling. In the grouping of thread cluster, thread grouping threads into two clusters, which is a TCM periodically ranks all threads according to the memory, which is an intensity of the fixed length time intervals called a quanta. And also this quanta places at least the memory intensive threads in the latency sensitive cluster and the remaining threads in the bandwidth sensitive cluster. This TCM throughout each quantum TCM monitors, which is a thread cluster memory, monitors the thread memory bandwidth usage in terms of memory cells. It has calculated across all the bands in the memory subset. And this thread cluster memory defines a thread memory service as time as the number of cycles that can bandwidth the The total memory bandwidth usages and the sum of each thread memory bandwidth is the total number of bandwidth is equal to the thread memory bandwidth usage. And this is all about the grouping of threads, and also it includes a group of threads into cluster. It is also a synchronized manner because across all the memory controllers to better exploit and band level parallelism, which is 4, 8, and 5, to appear on the same thread clustering. The memory controllers exchange the information at the end of every quanta, which is also known as quanta, as has been done in previous work. We set up time quantum length to million cycles, which is shortened to detect these changes in the thread memory. Long enough to minimize the communication over the synchronizing multiple memory controllers, which is a original paper show is pseudocode. But the thread clustering algorithm. And it also you can see the picture here. You can divide the cluster into two, which is a group, by using the group threads into two clusters. And the second step is prioritize non-intensive cluster. And the third step is different policies for each cluster. As we can see here, this is a picture of memory intensive and intensive cluster. And there are also niceness of this memory non-intensive. In memory intensive, we have threads in the system, and in non-intensive also we have threads, but in non-intensive cluster we have prioritized some high priority throughput, but in intensive cluster we have prioritized fairness. This is the difference between the non-intensive and the intensive clusters. Benefits of thread cluster. memory scheduling, which is also known as TCMS. Improved memory access latency for threads within the same cluster, reduced memory consumption, and improved overall system performance. And it is also affects the utilization of memory resources by prioritizing memory requests based on access pattern. And we can also see the picture of that cluster memory scheduling, which is a memory schedule in multi-core systems should carefully schedule memory requests and from the different threads, which is memory scheduling. There are challenges in TCM, which is a threat cluster memory scheduling, which identifies and grouping threads with similar memory access patterns, balancing the workload across the different thread clusters to avoid resource underutilization. As we can see the picture of the challenges, the maximum slowdown and fairness is less compared to the system thread. Balancing the workload across different thread clusters is the main reason for balancing the workload is to avoid resource underutilization. And last but not least has handling dynamically changing memory access pattern and workload variations. Thread cluster memory scheduling all the various algorithms such as round robin, proportional sort, and priority-based scheduling can be used for thread clusters. These algorithms aim these algorithms aim to optimize memory access for threads within the same cluster while ensuring fairness and resource utilization. The choice of algorithm depends on the specific requirements of the system and workload characteristics. The implementation cost is nothing but a required storage at memory controls, and there is no computation at all on the critical path. Implementation of that cluster memory scheduling. The implementation of that cluster memory scheduling can be implemented at the hardware level, software level, and a combination of both levels, which is hardware and software. Hardware-based implementations often involve programmable memory controllers, or we can say specialized memory management units. Software-based implementations utilize operating system levels schedulers to manage the cluster and memory access. This is a case study of Intel Thread Director. Intel Thread Director is a hardware-based thread cluster memory scheduling technology which is introduced in the Intel process. Dynamically groups threads into clusters based on their memory access patterns and optimize memory access for each cluster. Intel Thread Director aims to improve system performance, reduce memory contamination, and enhance overall user experience. As you can see, Intel Thread Director intelligence built into the core, which is the first part as an operating system scheduler. And the second is monitors that runs time with instructions with each thread and as well as the state of each core with nanosecond precision. It provides runtime feedback on the operating system to provide the optimal scheduling decision for any workload or workflow. Dynamically, it adopts guidance based on the thermal design point, operating conditions, and power settings without any user input. This is all about the case study of the Intel Thread Director. And next slide, which is performance level evaluation of the cluster memory schedule. Performance evaluation means a performance metrics such as memory access latency, throughput, and resource utilization, and used to evaluate the effectiveness of thread cluster memory scheduling. Benchmarks and workload simulations are often used to measure the impact of the cluster memory schedule on system performance. Real-world applications and use cases can provide valuable insights into the benefits and limitations of the cluster memory schedule. Next, there are the future trends in the cluster memory scheduling, which is advance in hardware and software technologies, but you can also say in the both technologies, and expected to further optimize the cluster memory scheduling. Machine learning and AI techniques may utilize to predict and adapt to changes memory access patterns. Integration of thread cluster memory scheduling with other system components such as cache management and task scheduling can lead to more efficient resource utilization. And here's a tiny slide of conclusion, which is the cluster memory scheduling conclusion. The thread cluster memory scheduling is a valuable technique for optimizing memory access in multi-threaded systems. But within threads with similar memory access patterns into clusters, it can reduce memory concentration and improve system performance. Continued research and development in the cluster memory scheduling can lead to more efficient and scalable memory management solutions. Thank you.